Okay, this is question 4 of the Where Did I Last See This strategy. This strategy asks you to think, does any part of this ring a bell from a topic that I've done before? So anyway, let's just have a bit of a muck around first. Small ink cartridge. So one cartridge is 600 pages. 3 small cartridges can print as many as... Okay, so this is just for small. 3 small cartridges can print as many as 2 medium cartridges. So medium, haven't got any information on any medium yet. Three small cartridges can print as many pages as 2 medium cartridges. So if it was 2, it'd be some mystery number of pages. Let's call that X. Just because I wanted to write something down, I wanted to reflect that it was equal, but I didn't know, so I just named it. 3 medium cartridges can print as many as 2 large. No, now I've got this large thing as well. Three medium. Okay, so I'm going to call as 2 large. Okay, now here's the thing, I was about to use a Y for that, to express the fact that 3 medium can do the same number of pages as 2 large. But here's the thing, this is the topic where if you double one thing, you double the other. That's where I've seen this before. So 2 becoming 3, that's dividing by 2, then timesing by 3. So that's that, so dividing by 2, then timesing by 3. And that is therefore the same. And, oh, there we go. If 1 does 600, then 3 does 1800. So that's 1800. So divide that by 2, you get 900. So there we go, that's the complete set of information. How many pages can be printed using a large cartridge? So it's 2,700. I'll just check that that's the answer. So that's 1350, which is half of that. So maybe I made a mistake. So a small one can do 600. 3 small can do X, which is clearly 1800. 2 medium can do the same as 3 small. So they're the same. And 3 medium can do the same as 2 large. Oh, here we go. The answer is not the figure for 2, it's the figure for 1. So again, if this is halving, this is halving, so that's why it's 1350, and that is your answer. That's how many pages 1 large cartridge can do. So that's question number 4. Question number 5. Pqrs is a quadrilateral inscribed in a circle. Now you always name around the circle, so it's like PQRS or PQRS. You don't ever zigzag, you don't go PQRS. So PQRS could work. I'm always telling people to not be afraid of messing things up, so I'll just write PQRS. But it now says that PQ is a PR is a diameter, so by chance that looks plausible. I'm just going to draw an O there to indicate that it's the diameter. Lengths of PQ, QR and RS. PQ, QR and RS are 60, 25 and 52. What is the length of SP? So our job is to find this. Now, where have I seen this before? Oh, this is circle geometry. Circle geometry says that this is a right angle, so now I can use Pythagoras. I'll call that y. So y squared equals 60 squared plus 25 squared. So therefore, also x squared plus 52 squared equals y squared. So therefore x squared equals 60 squared plus 25 squared minus 52 squared. Now I'm just going to try and be tricky here. That's different to 2 squares, so it's 60 plus 52, 60 minus 52, which is 112 times 8 plus 25 squared. That's 625. I don't know why I'm doing this without a calculator here. I think I'm just kind of showing off. Times your mate is doubling 3 times, so double once, 224, double again, 248, double one more time, 496. So x squared equals that plus that, which is 1000 and pretty sure I made a mistake here. Sorry, wait on, that's not 496. Double at once, 224. Double again, 448. Double at one last time is 896. So 896 plus 625 is calculator now. 896 plus 625 equals 1521, and the square root of that is 39. Now, by the way, if this was a non-calculated question, that's a classic example of the prime factorization strategy. If you factorize that and then write it out as a list of factors, I think it'll be 1521 equals 3 times 13 times 3 times 13. Remember, the square root is whatever you need to multiply by itself to give this, so therefore the square root of that is 3 times 13, which is 39. So that's question number 5. Question number 6. What's the minimum value of this? Oh, where have I seen this before? That's the reverse of the poem. That's just a good old-fashioned Year 8 factorization question. There's a bit of complexity here, so I'm going to just name something. W equals x plus y. It'll help keep my algebra skills in gear. My job is to find out the minimum value that this can be. Now, a couple of ways to work out a minimum. When you're in year 12 or when you're doing Ab Maths or year 13, you can use calculus. Another great way is to complete the square. So, just another use of the where have I seen this before strategy. Where have I seen this before? It's completing the square. So I think of it as hating what's in third position, bump that out, what I wish is there, halve this, then square it. Can't just add a 9, you've got to compensate as well. So what's the minimum that could be? Well, if you're squaring, it's going to keep it positive or 0, and then if you take off 5, so the minimum value that can be is -5. So that's the answer to question number 6. Question number 7. The ratio of two positive numbers, let's call them x and y, equals the ratio of their sum to their difference. So we'll say x is the bigger one. So these are the same. Now what is that ratio? Okay. So however x becomes y is the same as how x plus y becomes x minus y. How does x become y? Divide by x and then times by y. So where have I seen this before? It's the topic where if you double one thing, you double the other. So ratios is an example of that. So if you turn x into y by dividing by x and then times it by y, that must also be how this becomes that. So therefore x plus y over x is the same as x minus y times y. Gee, this is a tricky equation. Yeah. What shall I do? I suppose I could just work with this. Doesn't seem to help much. So I'll just start again. So let's say that instead of doing this in 2 stages, we call that just timesing by k. So in other words, x minus y, if you times that by k, you get x plus y. But what we can discover from this is that y equals kx. So therefore, k times x minus kx equals x plus kx. So kx minus k squared x equals x plus kx. Oh, look at that. No, wait on. I'm just going to cancel them out. So negative k squared x equals x. And if you divide both sides by x, you get negative k squared equals 1, but that can't be right because you can't get the square root of a negative number. So I must have made a mistake there. You going to check this? The ratio of two positive numbers equals the ratio of their sum to their difference. So the ratio of the two numbers is the ratio of their sum to their difference. There's the sum, there's the difference. Okay, so let's try it. If you divide that by that, you get the same as dividing that by that. So y divided by x equals x minus y over x plus y. Times both sides by x, you get this. times both sides by y, you get this. Oh, here we go. xy plus y squared equals x squared minus xy. So in other words, y squared plus 2xy minus x squared equals 0. Now here's the thing, where have I seen that before? And by the way, I'm still a bit worried about this. Don't understand what's going on now, I must have made a mistake. Really don't know what's going on there. But anyway, the question is, where have I seen this before? That's the quadratic formula. So, that's your A, that's your B, and that's your C. So, I can therefore say that y equals negative B plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So y equals negative 2x plus or minus the square root of 4x squared plus 4x squared all over 2. So therefore y equals negative 2x plus or minus the square root of 8x squared over 2. Now, just continuing that up there. Y equals negative 2x plus square root of 4, square root of 2, square root of x squared over 2 equals negative 2x plus 2 root 2 x squared. Oh, that's just an x. All over 2. So y equals negative x plus root 2x. So therefore, factorize this, you get root 2. So in other words, to get y, you need to times x by root 2 minus 1. So that's the ratio. So the ratio of x to y is 1 to root 2 minus 1. Now, the reason why that's not in the answer, by the way, is that that's actually the same thing. So watch this. If you times both sides of that by this, I think you get root 2 plus 1. That's squared. That's the same bracket twice, 1 to the plus, 1 to the minus. That's squared thing minus squared thing. That, so square that you get 2, square that you get 1. So there we go, that was the answer that was in the solutions.